Hello everyone, this is Math123 Vodcast from Group 6, and our members are Karen, Julia, Charlene, and Angela. So we are talking about the application of derivatives using cost function. Say, for example, let's have a look at the graph A, and this is a common total cost curve. The tangent line, point A and D, is the marginal cost, which is a special term economists use for the derivative of costs. Thus, cost added from producing an additional unit. From the graph B, the minimum cost occurs when the quantity equals to Q4, which is denoted from the graph that there is no rate of change. This would mean when marginal cost or the derivatives of the total cost function equals to 0. This also happens when it is a maximum and a horizontal inflection. We are selling organic lemon juice near Macquarie University, and our target customer is university students. In this project, we are hoping to find the minimum cost of running this business. As you can see, this is the total cost. A lot of our cost will be contributed to rent, employee wages, and electricity. Assuming that 75% electricity costs are fixed, it remains unchanged with the production of lemon juice. In addition, 25% of electricity will be contributed to the juicer, dispenser, and other electrical machine that will contribute to the production of a cup of a lemon juice. But that will vary depending on the quantity produced. The more quantity produced, the lower of the cost.
Before we make the function, we're going to make an assumption that we're going to exclude other factors that might affect cost, so that variable cost remains constant per unit of output. Saying that, let Q be the number of a cup of lemon juice that our company produced. Let fixed cost be FC and variable cost in terms of quantity produced be FC Q bracket. And let the equation of total cost in terms of the quantity produced be TC with Q bracket. In the next slide, you're going to know why we made another assumption. That is, let Q not equal to 0. After our research, we're able to figure out how our cost varies as a function of quantity over a month. Thus, we're able to identify two different types of cost, fixed cost and variable cost. And added together, it'll be total cost. Fixed cost is a cost that doesn't change with the units produced. No matter how much lemon juice produced, we still need to pay the rent, wages, and most of electricity. On the other hand, variable costs do change with the units produced. Raw materials such as lemons, cups, and etc. is part of variable cost. When we add both of them together, we will be able to find total cost. Now, saying that, let's go back to the function. Fixed cost is 12,330 and the variable cost is 1.3Q plus 1078 over Q. So the total cost function is 12,330 plus 1.3Q plus 1078 over Q. First, let's derive the total cost function, which is TC apostrophe bracket Q. It'll be 1.3 minus 1078 over Q squared. When the first derivative of total cost function equals 0, when we solve it, Q would be 29 or minus 29. But due to our assumptions, we can reject Q equals minus 29. When we plug in Q equals 29 in the total cost function, we'll find that it'll be equal to 12,405. What is Q when it's equal to 29? What does it mean? Well, it means when we produce 29 lemon juice per month, we'll be able to have the lowest minimum of total cost at 12,405. We can also see this from the graph below. After the point of 29, the total cost keeps increasing and increasing. This might be due to these economies of scale. This technique of analysis and presentation of costs helps us in taking many managerial decisions. However, this technique uses a lot of assumption, which may be misinterpreted, thus making errors under these circumstances. It'll also not apply across the board for all situations. An example would be some of the fixed costs of electricity also contributed to the production of lemonade, thus it is semi-variable in nature, which means it's very difficult and arbitrary to classify this cost into fixed and variable elements. Lastly, marginal cost is also not useful alone, as production of output at minimum of total cost doesn't equal maximum profit. Thus, we will need to use other methods to compare with, such as revenue.
It is important to notice that marginal cost is very important as it accounts for a large part of economic analysis and policy recommendation for each part of a society. For example, marginal cost is the additional environmental cost due to the production of one additional unit.